everywhere there's an x, after 3 equals 3 squared equals 9. Alright? Here, you put in x plus h wherever there's an x. Right? So you're going to put it in two different places. One, right? You're going to have f of x plus h equals x plus h squared. Alright? And I didn't give you very distinct instructions here. I wanted you to FOIL that out too. Alright? So what we did there is, instead of x, we put x plus h wherever there were x's, and then we FOILed out just like you would in Algebra 1. Right? X plus h times x plus h, and so on and so forth. Okay. That we will use later on in the class, so put those in your pockets.
Pocket.
Not literally your pockets, your like mental pockets.
Oh.
Okay. Alright, so homework, you had two different parts. Okay, for the first part, which is the rest of the questions that were in your notes, you didn't have very much to do, but I'm wondering, were you a little confused by this question right here? Yeah?
Yeah, go to that.
Let's go through that.
Alright.
Will you read it for me, Tristan?
Which one is it?
This is number 2 on the back, in the part about instantaneous rate of change. Tristan's still working on getting it out. I have stuff for you. Alright, Carly, you have it. Why don't you read it for me?
Water is leaking from the tank. The amount of water left in the tank, measured in thousands of liters after 8,000 liters.
Alright, so there we have it. That graph is showing water going out of the tank. So the amount of water is decreasing as time increases, right? Is the rate of change, is more water leaking out at the beginning or at the end?
Yeah.
At the beginning. How can you tell, Ramel?
It's more steep in the beginning.
It's more steep, right? I'd rather ride my bike down this part because I'd be going faster.
Woo.
Yeah. Alright, so the question, the first part is, how much water was in the tank originally? Did you answer that, Ariana? Yeah, and what did you say? 8,000 liters, because you would read that just like you'd read it in Algebra 2, right? You look at this graph, this axis is how much water there is, this axis is time. Well, if I'm looking at 0 time has passed initially, there's 8,000. I'm sorry this is blurry up here, but look at your sheets if you want clearer graphs. Okay, then how much water is in the tank after 1 hour? Chase? Around 3,000. Yeah, that looks about right. Yeah, if we go straight up here, 3,000, right there. Right, same way you do it in Algebra 2, again. Okay, C is a little bit different. Why is C different?
I don't know how to do it.
Because you don't know how to do it?
Yeah, I never learned that.
You did learn.
No,
I heard an important word back here. What was it, Philip? It's instantaneous, right?
Tangent.
It's asking about the rate of change, right? How quickly was the tank losing water? Initially meaning at 0 seconds, right? So at that second, at that instant, how much water was being lost? So how can you find that?
Average.
Average? Average is not instantaneous. Philip, did you? Not Philip. Michael, did you have an idea? No?
Just ask Philip already.
Alright.
Philip, tell us. Philip,
Chase.
tell us.
No, I really don't.
You guys, how do we look at instantaneous
Tangent.
change? Tangent lines. Right? Tangent lines. So what do we do with the tangent line, Ramel?
Like draw it?
You draw it?
Yeah.
Okay, so where did you draw it?
Oh, I didn't do that.
Okay, where would you draw it?
On the
asking at initially, so initially means at 0, right? So
Yeah.
everybody go ahead, draw your tangent line at t equals 0, right? Right, make a point on the line,
See, that line's crooked.
right there. And you have to draw a really straight line,
Yeah.
right? The tangent line only touches the line at one point. Draw that point at t equals 0.
If not, I'll give you mine. I'll just take it.
It says Joey, but pretend it says Houston. So you drew your tangent line, and now what do you have to do to find the rate of change?
And then you find some coordinates.
I hear Carly saying something important. What are you saying, Carly? Right, you're finding the slope of the tangent line, right? So you drew a really straight line through this point, right, that only touches the curve. Yeah, this is a really bad tangent line. And then you're finding the slope of this. What did you find as the slope, Philip? Okay, you found a very accurate slope, all right? But it should be not negative, and
Yeah, I didn't know.
it is right negative because it's asking for the slope. I can understand why you wouldn't.
I got roughly negative 7,000. Is that in the range?
I actually think it looks more like negative 4,000.
Yeah, that's what I got.
Right? Doesn't it?
Yeah.
Doesn't that slope look like it's more like 4,000?
Yeah.
4,000?
Okay. So anyone with anything other than 4,000 is wrong. Why do you say that?
Well, if I'm looking at a line that,
Ovos?
so here's my point, right? I'm looking at a tangent line that's going out about right there. So I'm maybe gonna use,
Here if I call it the word. Oh my gosh.
Are you serious?
Okay. Okay, Mr. 1500.
well,
But like this is one, that's 1,000. If you have it like this, when you get down to 1, it's gonna be down here somewhere.
right, so to use these 2 points here.
I use this point and then made the tangent line whatever. So like after 1, it's down here,
Okay.
like below 2.
I'm looking at, it looks like to me that it's gonna be about 0.56,000 here, and negative 10,000 up here, and that's where I got negative 4,000. You guys, as I said earlier, this is not an accurate way of finding tangents, right? It's not an accurate way of finding rate of change, so there is gonna be a good bit of variation in
Yeah, so-
what it is, alright?
Easy on the
But I'd
other
say,
side.
what I'd wanna see here, guys, what I'd wanna see is a tangent line with a negative slope that looks like it's going through this point and this point only on the graph, and an attempt to find 2 points on that line and find the slope in between them. That's what I'd look for, alright? I wouldn't be real strict on the accuracy.
I use that
Okay, I would accept that, yeah. Yep. Alright, so how quickly was the tank losing water after 1 hour? What are we gonna do here?
Draw a tangent line at about an hour.
Look at an hour right there, draw a point, draw a tangent line through it, and find the rate of change of that tangent line, the slope of that tangent line, using the gradient formula.
Ow.
Alright, so I'm not necessarily looking for a really accurate gradient, right? Because as Philip and I were discussing, there is a lot of variation in how you might draw that, because this is not an accurate way of finding that rate of change actually. But I would want to wanna see that you understand the concepts that we're looking for, that it is the rate of change at that point and the tangent line finds it, right? Okay. Then let's go to the other part of your homework,
Is there not like
which was this.
answers?
What was that?
Is there not like textbook answers or whatever to those questions?
There's procedural answers, and I'd wanna see a tangent line, and I'd wanna see that you had found the gradient of that tangent line, but they're not gonna ask for super accurate tangent lines, this is really hard to do. Alright. This one here